Here we are looking to evaluate two limits at infinity. For part A, we have the limit as x goes to infinity of the quantity x to the fourth plus 3x squared plus 2x plus 1 all over the quantity x to the fifth minus 9x minus 1. Okay, well, let's start with the fast way. The fast way from precalculus, and I won't go too much into depth with this, I'll refer you to your precalculus or even kind of an intermediate algebra text would do the trick. The fast way says anytime the degree of the denominator is higher than that of the numerator, so we have x to the fifth down below, x to the fourth up top, anytime x is going to infinity or negative infinity, and the degree of the denominator is higher, it's automatically 0. Done. Check out your pre-calc notes for more on that. The reason why we don't just say that and move on is because there's a more general method that we'll use in calculus that'll be applicable to way more problems. So here's the key. Divide everything by the largest power in the denominator. What I mean by that is, in this example here, look at the denominator. We have x to the fifth. So that's what I mean by the largest power. So I'm going to divide every single term by x to the fifth, x to the fifth, x to the fifth. All right, so we do this again and again and again. X to the fifth, all over x to the fifth. Okay, x to the fifth. And you can probably reason through this pretty quickly from here, just in your head, but I'll write it out just to be on the safe side. So this becomes then the limit as x goes to infinity of 1 over x plus 3 over x squared plus 2 over x to the fourth plus 1 over x to the fifth up top. All of that over, well, x to the fifth over x to the fifth is 1, minus 9 over x to the fourth, minus 1 over x to the fifth. Now as we let x run out to infinity, all these terms are going to go to 0. Right? So all these terms with x in the denominator all go to 0 because x going to infinity just pulls all those down to 0. Well, now we've evaluated the limit, so we don't have to write limit anymore. And what are we left with? 0 over 1, which clearly equals 0. So a slightly longer method, but a far more universal method. Let's take a look at B. We have the limit as x goes to infinity of the quantity 3x cubed minus 2x minus 8 all over the quantity 5x cubed plus x squared plus 7x minus 5. Okay, let's start by doing things the fast but not particularly universal way, the fast precalculus way. And again, I refer you to your precalculus notes for this, or just find a precalculus book if you didn't take precalculus. And what the precalculus method says is that anytime the degree of the numerator and denominator are tied, so here we have 3 and 3, the limit is then the ratio of these leading coefficients. So this would be 3/5. But why do it the easy way when you can do it the much harder and more involved way? Well, because the more involved way is more universal, and we'll need this technique in more challenging exercises. So we find the largest power in the denominator, that's x cubed, divide every single term by that. So I'm dividing everything by x cubed, just as before, same idea, right? Everything in the numerator and in the denominator. And again, why can we do this? Well, we're just really multiplying by 1 over x cubed in the numerator and the denominator, just so we're mathematically sound. 1 over x cubed over 1 over x cubed is 1. So we're not changing anything mathematically here. Okay, well, this leaves us with the limit as x goes to infinity still. Okay, well, what do we have up top? We have 3 minus 2 over x squared minus 8 over x cubed all over. Down below we have 5 plus 1 over x plus 7 over x squared minus 5 over x cubed. Okay, and for the same reasons as before, anything with just a number up top and then x on the bottom goes to 0 as x goes to infinity. So those two terms on the top go to 0, and these three terms on the bottom go to 0, leaving us with 3/5 as expected.